Hello Mr. Tan, I'm Anwarul Adzizi bin Adeni with metric number 200304885, a master student of MITM course, and now I'm presenting to you TMF 6044 ICT Infrastructure Assignment titled Distributed Cloud. So let us look into the history of distributed cloud. The history of distributed cloud can be traced back in 1970s, whereby computing resources are pooled and connected through local area networks, LAN, such as Ethernet, okay, which is more private. And in 1980s, there are more large-scale networks such as Usenet, ARPANET, and FidoNet, which are proprietary in nature, and establishment of distributed computing as its own discipline. And in 1980s, it's getting more advanced as specification and technology demand become higher. While in 2000s, there are more widespread use of internet and there are increased bandwidth, whereby people are going from modem, 64K modem, 32K modem, through more advanced broadband such as ASDL, okay, and fiber optics. And then now business owners mostly aim to reduce investment on ICT infrastructure without thinking about maintenance, and introduce scalability, ease of upgrading or expansion without more investment. In 2006, Amazon introduced cloud computing services in form of Infrastructure as a Service or IaaS, and increased requirements on cloud computing led to more companies offering cloud computing services like Microsoft Azure. So let us look into what is distributed cloud. So distributed cloud is an interconnecting cloud. For example, the edge cloud, okay, whereby computing and data storage closer to the location to save bandwidth. It's closer to the users. And edge cloud will connect to the regional cloud, which acts as a middle layer connecting to various edge clouds. And the regional cloud will connect to the public cloud, whereby the central cloud provided by the cloud service providers can be accessed from different regional clouds. And services offered from this cloud, such as SaaS, Software as a Service, PaaS, Platform as a Service, and IaaS, Infrastructure as a Service. So this cloud is basically distributed geographically in various locations in form of cloud replica. Okay, so cloud replica is located according to the nearest location to ensure reliability and quality of services. And because nearest location is there to reduce network transmission time. In the event of failure of one cloud, another replica can instantly boot to run. So this is how distributed cloud is why it's become a trend right now. So I would like to elaborate more on problem that motivate the trend. So basically, why we need distributed cloud? First, because we require because more businesses are going towards cloud, and they want to have to reduce transmission time. They also want to reduce latency, and they want to improve efficiencies. So I would like to take example of water supply services. Okay, for example, in JBAP, our Jabatan Bekalan Air Luar Bandar, where I'm working now, we have this cloud solution for water supply production. Okay, whereby all the data collected from various PLCs, various IoTs are collected to a central data centers in the water treatment plant. Okay, this is to minimize transmission, whereby the data is processed locally in the water treatment plant before being transmitted to the cloud, as you can see from the diagram here. And then after that, the cloud will be connected through various means. For example, we have reservoir monitoring that connect to the cloud, specific cloud, which is normally proprietary. Pipeline monitoring, also cloud, connecting to the cloud. High level tank monitoring and water treatment plant monitoring just now also connect to the cloud. And after that, the cloud will also act as a middle person to the IoT installed on the ground, and also to the backup server, and also to the public cloud. This is what we can see, the example of the cloud concept in water supply services. And what motivates me to choose this topic? Because first, we would like to look into environment sustainability, okay? Because we want to have sustainable use of water supply, limited, scarce, and vital to human needs. So when we have a sustainable environment, it can be achieved through use of clouds, whereby all the data can be stored in the cloud and processed in the cloud. And we also would like to see prudent government expenditure to ensure government expenditure is well spent for what is worth, prudent and responsibly spent. And I would like also to contribute to Sarawak development with effective consumption monitoring. Okay, we need to say we have this cloud as a way to store and process data. We can have effective consumption monitoring. Water supply planning will be made easier to facilitate development of Sarawak. And it will also improve to government services and sense of empathy toward rural communities, also one of the motivation. So let us look into the chosen papers. Okay, so I have chosen 3 papers, okay, which is paper number 1, this by Cody et al. 2015, Distributed Cloud Computing Application Status Quo and Challenges. Paper number 2 from Keller et al. 2014, Response Time Optimized Distributed Cloud Resource Allocations. And paper number 3, Ludwig et al. 2015, Distributed Cloud Market, Who Benefits from Specification Flexibilities. Okay, so I will go through this paper one by one. Okay, for paper number 1, for each paper I will elaborate into the problem statement, research objective, research method, and research significance. For paper number 1, the problem statement is public cloud computing technology concentrating on deployment of centralized data servers in huge number. However, the drawback, owners do not replicate services across zones, therefore higher dropout. So they require more control on network latency for some applications to data center, and also data center issues such as land use, power usage, and bandwidth requirement. So basically, paper number 1 will look into the applications of distributed cloud computing, status quo, and the challenges. Research objective for this paper is to discuss challenges in distributed cloud. Distributed cloud as cost-effective way, ensure replica can be instantly booted after failures of another cloud servers. Reduce costs, provide reliability, redundancy, and geo-replication. Application to benefit such as machine-to-machine communication, VR, AR, AI, and smart grid control. Research method. The research method are they look into the challenges. Actually, this paper is not really, it's a collection of different findings and different outcomes from a symposium that was presented by a committee. So they are more into like looking into the challenges and the applications and the status quo of distributed cloud, rather than researching on something, a specific research. So the research method is, I can elaborate like the challenges such as programmability, consistency, privacy and security, proper programming model identification, distributed cloud computing abstraction and primitives, and in possible future, numerous devices with different automation and requirement on latency and high availability may connect to distributed cloud. So they will look into how the challenges will be foreseen in the future. and enhance privacy through storing data locally within geographic region. And the research significance of this paper is actually because this paper discusses a lot on the challenges. So it is very significant in the world today because distributed cloud is widely used and available. So business owners, especially when they when they read through this paper, they will look into the challenges on the distributed cloud environment. And in water agencies like JBAB, we will look into how to fully utilize distributed cloud resources based on geolocations and requirements to ensure reliability and performance. And then after that, we will look into the challenges. Okay, so the challenges in this paper too are they are trying to answer several motivational questions, such as programmability, what are suitable programming models for wide area clouds, details on resources, okay, and consistency, such as what consistency models required in distributed cloud, deployment model, federated versus integrated versus autonomous, and support for network virtualization going out of data center and between data center itself. And another question is privacy and security. What can they benefit from in terms of privacy and security? And other motivational questions which touches more on economics of distributed cloud deployment, cheaper or more expensive than centralized cloud, and how to conduct experiments on distributed clouds, scalability and repeatability. So in paper 2, the title is Response Time Optimized Distributed Cloud Resource Allocation. So basically paper 2 discusses on the problem statement, discusses on the like future, because in the future many computing resources available across geographical locations, meaning to say when we do cloud computing there are always cloud computing server that is closer to the developer. And then to reduce request response time from the consumers, server nearer to the user to minimize network transmission time. The problem, which is the data center is heavily loaded with requests, reduce processing times and reliability. Okay, meaning to say because of a lot of these servers are located geographically, meaning to say when one processing request was submitted to one particular data center which is nearer to the consumer, to the user, there will be a tendency of certain data center to be heavily loaded with requests. So this paper also highlight the problem on need to balance amount of data centers, response processing time, utilize resources, and reduce expenses. And the research objective of this paper is to model a facility location problem, whereby they will try to find the most optimal assignments of user requests to data centers limited in resources, reduce cost of the average user request response, focusing on load balancing, trade-off between response time and resource utilization, and calculate optimal solutions and maximal error. Or in other words, the research objective is actually to model the facility location problem that can address all these issues. Okay. And the research method is they would try to create a scenario of capacitated facility location where data centers as candidate location for server to run represented in facility nodes, and there are client nodes that commensurate to locations where flows of user requests enter the network, identify open facilities and assignment of client demand to facilities, and problem the model algorithm to reassess current load condition, convex optimization, and linear approximation. And this research is very significant because it presented solution for resource optimization, reducing response time and reduce cost, model assignment between facility nodes and client nodes using response time and latency. So these are the example of the problem model, whereby even though it's a little bit more on the technical side, but what I can understand from this model is they will look into the maximum error, the convex model, price-wise linearization, and after that it will evaluate based on the topology. In paper number 3, which is distributed cloud market, who benefits from specification flexibilities? Okay, the problem is, statement is, data centers become hosts of many applications with varying requirements. Some applications require heavy network sensitive to latency, strict deadlines, and quality of service networking guarantee. Service providers have algorithm programmed to different requirements and specification, and who benefit from the flexible specifications. So if paper 1 we look into the challenges of the distributed cloud, paper 2 will look into the how to optimize the model to optimize the processing time and the response and the latency. Paper 3 will look into the more benefits, like who benefits more, like user, like the broker or the service provider. Okay, so the research objective of this paper is to address question of beneficiaries of distributed cloud specification flexibilities. They look into horizontal market, where they look into the providers and customers perspective, whereby the customers will end the request to the provider, and in vertical market, whereby it using brokers to bulk purchase cloud resources and resell at customers and provider, and looking at the providers, customers, and brokers perspective. And the research method will look into these two horizontal and vertical market, and they will look the insight into the customer's perspective and the provider's perspective, and insight into the broker's perspective, and what are the benefits they can gain from these specification flexibilities. And research significance. It is important to business owners because response time and price paid are important parameters in their business. It also highlights benefits gains from customers and service providers, including brokers' perspective. And they will look into if the inflexible customer, meaning customer is not flexible, so they may benefit less in terms of this service, and it will give more benefit to providers for more business opportunities, whereby brokers can benefit based on their strategy. So in paper 3, it can be summarized as follows. Okay, they look into the horizontal and vertical market, an analysis on broker's perspective, analysis of provider's perspective, and analysis on customer's perspective. So the conclusion, distributed cloud, because distributed cloud is something that will increase requirements day by day. Okay, more advanced technology using cloud computing require fast response time, reduced latency, such as cloud gaming, VR, AR, machine learning, and artificial intelligence. And business owners or users also would like to reduce costs and improve efficiencies. And distributed clouds has gained ever more importance after COVID-19, where more people working from home remotely and companies put less investment on IT infrastructure. Companies would rather invest more on better deals on cloud services with higher availability and more flexibility. So that is my presentation on distributed cloud, and thank you so much, Dr. Tan.